be inserted and removed by the patient. Accurately resist dislodging they preserve the health of patient's remaining teeth and relate. And the last one, this one is the skeletal denture. And as you see, the difference between two of them, the first difference we can notice is the base. Here the base is made of the acrylic resin, and here the base is made of this is the metal framework. So we've got two types of the class type removable partial dentures: metal framework denture, cast denture, skeletal dentures, partial denture. These are the names of the same denture, and the partial denture is the most common name which is used in the literature. And the second type of removable partial denture, this is the acrylic partial denture, in other words, temporary partial denture and acrylic denture. And as I told you, the difference between them is that the base, in case of the metal framework denture, is the metal framework, and in the case of acrylic partial denture, the base is made from the acrylic resin. But what else? In the case of the removable partial denture, RPD, the metal framework denture, this is the prosthetic appliance with reduced base. As you can see, we can make this base shorter because in the case of the skeleton denture, we've got some elements which can be placed on the occlusal part of the teeth and make the role of supporting elements. And thanks to that, this denture can be supported in two ways. So it can be supported on teeth, tooth-borne, in the case of edentulous arches bounded by remaining teeth. And this is an example of such a denture. As you can see, this is the gap between the teeth, and we can put the skeletal denture between them. And here you can see the metal tips which are placed on the occlusal surface of the teeth, and thanks to them, this denture is supported by the bone teeth of the patient. So this kind of denture is called tooth-supported denture. And another one, so teeth and mucosa, tooth mucosa-borne denture in the case of the posterior edentulous area. As you can see here, this denture is supported also by the teeth and by the mucosa because we've got the posterior edentulous area. So this is the tooth-supported denture, and this is the tooth and tissue-supported denture. So skeletal denture is made by casting methods, different from other partial denture in the fact that its metal framework is cast in a one piece. So as you see here, this is the example of upper one and the example of lower one. Practically all cast frameworks for removable partial denture are made of a chromium cobalt alloy. This is the special alloy because chromium cobalt alloys are used many times more than the gold or titanium alloys in removable partial prosthetics, and the popularity of the chromium cobalt alloys has been attributed to their low density, weight, and high modulus of elasticity, stiffness, low material cost, and resistant to tarnish. And the most important is the high modulus of elasticity, stiffness. And here have the example of metal framework of the skeletal denture. This is the upper one and the lower one, and the lower one presented on the gypsum model.
Sorry,
And
Professor.
yes.
At which slide you are in?
Which what?
Yes,
Please repeat.
Yes, because now my computer showed me that you are at slide 4, but I think you already.
No. Yes, the 7 one. So something's wrong.
Yes.
Okay, so maybe I stop sharing the screen and try to make once again. Okay. Just wait a second. I don't know why. No.
Oh, Professor, I think because you are also sharing your camera at the same time, and it will take some like internet speed. So
yes.
So I think
you're right.
If you close that, it will be smooth.
Okay, so I turn off my camera, yes, and suppose it should be better, yes?
Yes, I think so.
Okay, so wait. Okay. Okay, yes. Okay, now I stop the camera and again I try to share the screen with you. This is the slide number 4, yes? Do you see?
No, I see it's number 7.
Okay, and now number 4. Yes?
Yes, now number 4.
Okay, this is number 5.
Yes, okay. I think it's 5 now. Thank you.
Okay, 6. I showed you, yes, the metal framework, and now we are on the 7th one. Yes.
Oh, okay. Yes, it's correct.
Thank you so much. Thank you so much. Yeah, thank you. And please pay attention on everything, okay? If something is wrong, please tell me.
Okay.
Thank you so much. Okay, so let's come back. This is the examples of the skeletal denture, and on the previous slide you saw only the metal framework, and now you see the metal framework together with the acrylic base and artificial acrylic teeth. Of course, this is the upper one and this is the lower one. Okay, so that's about the principal components of a typical partial denture. So we can see the retaining elements, direct retainers, and it can be clasps and others like.
I'm sorry.
Yes.
I'm very sorry because now I think you go to the 8, right?
11.
Oh, you go to the 11, but in my it's still the 7.
Oh my God. I don't know why. And now, do you see the 8 one?
No, it's still the 7.
Oh my God, I don't know why. Okay, once again, I'll try. Something changed with the teams. I don't know why. And now, do you see the slide number 7?
Not yet. It's black. There's no input yet.
Okay. Okay, and now, what do you see?
Now I see the slide number 7.
Number 7, okay. And now, do you see that I'm changing the slide?
Yes, it's number 8.
Number 8, okay. Okay, so maybe I will be telling you that I'm changing the slide, okay?
Okay, thank you very much.
And you will tell me if you see it or not, okay?
Okay.
Okay. So, once again, principal components of a typical partial denture. These are the retaining elements, indirect retainers, supporting elements, connecting elements, saddles, acrylic base, and acrylic teeth. Next slide.
Yes, it's number 9.
Okay. So here you have an example of the upper skeletal denture. And here you have the principal elements of the skeletal denture, and they are marked by the colors. The retaining elements are marked by the green color, and you can see it here. These are the clasps in this case, and the retaining elements provide the retention of the denture. The red one, these are the supporting elements, in other words, the rests. So you see it here, the red color. Then we have the major connector, which connects both elements from the right and left sides. This is the major connector. Then we see the yellow one, the denture saddles. And the last but not least, the bracing and reciprocation elements. These are the blue ones, and those elements provide the stabilization of the denture. And what about the lower one? Next slide.
Yes.
This is the lower denture, and you see the same. So the green one, supporting elements, the red one, the green one, retention elements, the red one, supporting elements, the black one, connecting elements, the yellow one, saddle, and the blue one, bracing elements, which provide the stabilization of the denture. Next slide. Let's start talk about the retaining elements first. Retaining elements, in other words, direct retainers, they enable to retain the denture on the denture burning area. They are placed on the abutment teeth, and they provide resistance while removing the denture along the path of insertion. So here you have the example of such a retaining element. This is the clasp. Relative to the vertical and horizontal chewing forces, they prevent the denture movements. Next slide. So, a retainer is defined as any type of clasp, attachment, device, etc., used for the fixation, stabilization, or retention of prosthesis. And a direct retainer is that component of a removable partial denture used to retain or prevent dislodgement. It consists of a clasp assembly or precision attachment. So, because of that, we've got two types of direct retainers. Extracoronal retainer, this is the clasp type. This is the most commonly used retainer for RPD, so removable partial denture, and you can see on the picture, as you see here, many types of clasps. And another one, intracoronal retainer, in other words, internal retainer, internal attachment, precision attachment. This is the device which can be used for the skeletal dentures, and thanks to that device, Of course, the precision attach also provide the retention, and this is the much more aesthetic than the clasp type. And the term internal attachment is preferred over the precision attachment. Next slide. So a direct retainer as a clasp is commonly, it is commonly called a clasp or clasp unit. And it's composed of 4 elements. So here we have the retentive arm, the reciprocal arm, the rest, so some kind of supporting element, and a minor connector which connects the clasp with other elements of the skeletal denture. So this is the clasp unit. And remember, it consists of 4 elements. Next slide. And what does it mean, internal attachment? Internal attachment refers to an interlocking device. So one component is fixed to an abutment, as you see here. Of course, this is the bridge made for our patient, while the other is integrated into a removable prosthesis to stabilize or retain it. So as you see, we've got a ball and a hole, and they fix together, as you see here. And thanks to it, such an element provides the retention, and this is the much more aesthetic one than the clasp device. So internal retainer consists of a key and keyway with extremely small tolerance. And keyways male are contained within abutment crowns. So here, this is the male one, keyways. And keys female are attached to removable partial denture framework. Frictional resistance to removal and placement and limitation of movement serve to retain and stabilize the denture. Next slide. So another example of internal attachment. As you see here, this is the male part, and the female part is connected with the denture. So remember that in the case of the skeletal denture, we've got 2 types of the retaining elements. These are the clasp types, so external one, and internal one, which is called the precision attachment. Okay, and what does it mean, indirect retainers? The term indirect retainer denotes a part of a removable partial denture that assists the direct retainers in preventing displacements of distal extension denture bases by resisting lever actions from the opposite side of the fulcrum line. The most frequently used is auxiliary occlusal rest, as you see on the picture, this one. Located as far as possible from distal extension base, placed perpendicular to the middle point of the fulcrum line. So here we have the fulcrum line, and this is the middle point of the fulcrum line, and they are placed as far as possible from distal extension base. Next slide. Indirect retainer prevents rotational displacement of the denture about the rest of the principal abutment teeth. So thanks to this part of the skeletal denture, it is impossible to rotate the denture in the patient's mouth. Indirect retainers can be some reciprocal arms, so you see blue ones. So they can play the role of the indirect retainers. It can be also some elements of minor connectors, and also some supporting elements like rests in some clinical cases, as you see here. And the next slide. On this slide, you also can notice the main elements of the denture, like a major connector, so this one, both elements on the right side, a minor connector, like this one, direct retainer clasp, C1, indirect retainer D, so this is the small tip which is placed here to prevent dislodging forces, and a denture base, so this is the letter E. And of course the clasp, you see retentive arm, reciprocal arm, and the rest. Okay, so I hope that now you know what does it mean retentive elements of the skeletal denture. Remember, it can be two of them, clasp type and precision attachment. And now let's talk about the second element of the skeletal denture. These are the supporting elements, so rests. They are metal tips based on the occlusal surfaces or incisal edges of the abutment tooth. They enable to transfer the chewing forces through the abutment tooth to the bone. Thanks to it, they reduce vertical settling on the mucosa and horizontal movements of the denture, and they play the role of stabilizers. On this picture, you can see the one of the example of the supporting elements, which is placed on the occlusal surface of the tooth. Okay. Next slide. They can be independent tips coming out directly from the major connector. So you can see here, independent tip, can be independent tip, and then they play the role of the indirect retainers. But they may be also an integral part of the clasp. Integral part of the clasp, like you see here, this is the retentive arm, reciprocal arm, and the rest. What can we say about the functions of supporting elements? They transfer the vertical chewing forces, yes, because they are placed on the teeth. They prevent the food storage on the border of the saddle with the abutment tooth. They act as indirect clasp retainer, like you see here, so it can be independent tip. So they act as indirect clasp and additional support for the major connectors. They are used as onlay. They improve occlusal contacts. So when the supporting elements is the tip connected with the clasp, it can play the role of the onlay. And supporting elements also prevent extrusion of abutments. The supporting elements, the rest, should be placed perpendicularly to the long axis line. This is the rest, the tip, and it should be placed perpendicularly to the long axis line. This is the right one, this is the wrong one, and the wrong one, because the tip is not placed perpendicularly to the long axis line of the tooth. Oblique placement, the long axis line, may cause the tooth replacement, especially when the rest is not a part of the clasp, but just an independent tip. The place for the rest is marked after the analysis of the opposing occlusal contacts. You see here on the gypsum model, all the time we should analyze the models and find the proper place to put the supporting elements. And of course, we need to have a space for the supporting elements. So if there is no proper space for the rest, you should create it artificially. The rest to truly touch the tooth surface being its negative. And here on the picture, you can see here and here the metal tip, which is placed on the occlusal surface, of course, and the special place was made artificially to put this metal tip on the occlusal surface. So the rest supporting point, it's a partial dental element which lies on the tooth surface providing the horizontal support. Yes, so this is the metal element which lies on the tooth. And rest seat, supporting place, it's an abutment tooth surface prepared for the supporting point. So this is the portion of a tooth prepared to receive a rest. And as you see here, it can be made artificial if there is no proper space for the rest. It can be made artificially using the burr and the handpiece. So we should make a place for the to receive a rest. And what are the principles for the rest seat preparation? So if we need to prepare the rest seat for the rest, we need to know we need to make some principles. So first, the cross section. What shape should be visible, should be made for the rest? This is a close to rounded triangular shape. Apex is placed near the center of the occlusal part of the tooth, and the base is placed here. The area of the rest seat should be 2 to 10 quarter millimeters. So remember the rounded triangular shape. In the longitudinal section, the shape resembles a spoon. So this is the rounded semicircle. Floor should be concave or spoon shaped. The deepest portion should be placed in the center of the triangular shape. Sorry. And now the next slide. The width of the rest seat should be equal in length. So the width is equal with the length. And the base of the triangle is approximately 2.5 millimeters in length. The thickness of the rest at the junction, the prosthesis, should be about approximately 1.5 millimeters. So here 1.5 millimeters. And the base of the triangle, so rest seat, this base should be 1/3 the buccolingual width of the tooth. So you see, we can divide the tooth into 3 parts, and the base of the rest seat is the 1/3 of the buccolingual width. So the rest support types, depending on the distance of the rest from the gap, we can see the close support, distant support, and fast support. And depending on the location placement on the tooth, low support and high support. Let's talk first about the close support. The close support is when the rest is placed on the occlusal surface of the tooth directly bordering the gap. So here we have the rest, one of them, and the second one. And the rests, those tips are placed on the occlusal surface of the tooth directly bordering the gap. And this is the close support. And how it's look on the model or on the skeletal denture, as you can see here. So directly, they are placed directly to the gap. See here, and it is called close support. Yes, when it is placed directly to the gap. And now distant support. The rest is placed on the tooth bordering the gap, but on the tooth occlusal surface opposite the gap. So here we have the gap, the abutment tooth and the abutment tooth, and the rest is placed on the surface, on the occlusal surface opposite the gap. So here and here. And how it look on the model. The rest seat is made here on the occlusal surface opposite the gap. Here and here and also here. This is the distant support. And the last one, far support. The rest is placed on the second or distal tooth from the gap. On the second or distal tooth from the gap. This is the far support. And when we come back to this picture, you can notice the distant support and the far support, which is placed on the second tooth of the gap. Let's come back to the close support again. So this is the close support, And this kind of support we design when we have the third Kennedy class so when we have the gap bordering by remaining teeth. So then you can design the close support. What about the distant and the far support? Such kind of supports we can design in the case of the first and second Kennedy class. So in the case when we have the posterior edentulous area. In such cases, you can't design the close support, only the distant or far or both of them. Okay, and also we can say about the high support and low support. What are the difference between them? The high support is placed on the occlusal part of the tooth, and the low support is placed, as you see, much more lower than the occlusal surface. And what about the rest types according to McCracken? We can divide it into two parts, direct and indirect. Direct are located on the tooth surface hitting the gap, and indirect located on the tooth distance from the gap. So direct in this case is the same as a close support, and indirect the same as a distant and far support. In case of the denture which rebuilds the unilateral or bilateral posterior edentulous area, the rest called indirect retainer, this one, should be moved from the free saddle of the denture as far as possible and located on the tooth which is able to take the extra forces, extra loads. So I told you on the previous slides about the indirect retainers, and this is the example of indirect retainers. It is placed as far as possible from the free saddle of the denture. Okay, what else? Yes. And to sum up, here you have the types of the rest seat forms. So this is an example of occlusal one, round lingual one, so the low support, lingual or cingulum, and incisal one. And again, next slide. This is the occlusal one, the most common, the occlusal one, cingulum one, and incisal one. Okay. And some rules of placing the supporting elements, the rests. Placing the rest should be designed in such a way so as the biggest part of the denture bearing area was placed inside the feature shape created by the rest connected by the straight line. If the part of the denture with artificial teeth will be sticking out of the shape, the axis of rotation and the attempts to raise it upward will occur during the pressure on that fragment. In the situation when on one side there is a toothless arch, the denture will turn to sit down on it and moving along the axis of rotation. And the axis of rotation always occurs on the closest supporting elements in relation to the place where the denture sit down. Okay, so that was everything about the supporting elements. And now let's go to the connecting elements. So connectors can be classified as either minor or major. Minor connectors are marked using pink color, and major connectors using the black color. Okay, so what does it mean, minor connectors? These are the stiff structures, unit of a partial denture coming out from the major connectors. They connect other elements together of the skeletal denture. They also join small elements like clasps, rests with the denture saddle and base. The principal function of minor connectors are to provide unification and rigidity to the denture. And major connector, it is the part of a removable partial denture that connects the components on one side of the arch to the components on the opposite side of the arch. As you see, the black one, this is the major connector. And functions, they unit all other components of a partial denture so that the partial denture acts as one unit. It provides rigidity to the denture. We've got some kinds of the major connectors. The examples, in the case of the upper denture and lower denture. In the case of the upper denture, there are palatal strap, anterior-posterior palatal strap, U-shaped palatal major connector, palatal plate, and ring connector. In the case of the lower denture, these are the lingual or sublingual bar, dental lingual bar, lingual plate, labial or buccal bar. So now I would like to show you an examples of such major connectors. Let's start from the upper connectors, maxillary major connector types. And first one, this is the palatal strap. So this is an example of the palatal strap. These are some rules of making the palatal strap. This is the most common maxillary major connector. The minimal width can be smaller than 8 to 10 millimeters. So this dimension should be 8 to 10 millimeters. Borders should be rounded and thicker by about 0.5 millimeter. Thus, a construction is stiffer and not harmful. So as I told you, this is the most common maxillary major connector. Next one, sorry. So this is the palatal strap, the most common, the first one. And now the second one, anterior-posterior palatal strap. The anterior strap is placed among the palatal folds and the posterior strap close to the soft palate. And you see between them is a hole, and the distance between these two straps should be at least 15 millimeters. And when can such a connector can be used? In the case when we have the very big palatal middle sheath. So here, when this palatal part is very big, we can use the anterior-posterior palatal strap. Here we have the third example, the U-shaped palatal major connector. This is the least useful of all maxillary palatal connectors, but you should know that such kind exists. And the fourth one, the palatal plate, it is recommended only in case of the wide tooth gaps when the alveolar process is resorted. This connector doesn't provide a good support for the denture, but as you see, such kind of maxillary major connector exists, and you should know that in some cases we can use such kind of connector. And the last one, ring connector, it is used in cases when we have many gaps between the teeth, as you see on the picture. And what about the mandibular major connectors types? The first one is a lingual bar. Lingual bar is placed, as you see here. This lingual bar should be placed as low as the functional depth of the lingual sulcus will allow. You see here. The maximum cross-sectional dimension of this connector is oriented vertically. Its height should be at least 4 millimeters, and the distance between the upper border and level of the gingiva should be 3 millimeters. So as you see, the depth of the sulcus should be at least 7 millimeters. And this is the example of the lingual bar. This is also the very common connector using in the case of the mandibula. The second one, sublingual bar. This is the very similar one to the lingual bar. The sublingual bar differs from the lingual bar in depth, its dimensions. So that its dimensions are determined by the specialized master impression technique that accurately records the functional depth and width of the lingual sulcus. So the lingual and sublingual bar, we can say these are the same, almost the same, and those major connectors are very common when we talk about the mandibular connectors. The third one, dental bar. This is the homogeneous metal strip which is situated on the upper lingual surface of the lower teeth, as you see here, upper lingual surface of the lower teeth. On occasions, there is insufficient space between gingival margin and floor of the mouth for either a sublingual or lingual bar. So in such cases, when you see here, there is no depth of the sulcus. In such cases, we can design the dental bar. Students, wait a second. I will come back. Okay, let's come back. So that was the dental bar. And now the fourth one, the dental lingual bar, sometimes referred to as a Kennedy bar, or continuous clasp consists of the dental bar and combined with the lingual bar. So you see together, dental bar and lingual bar together. Dental bar and lingual bar. Dental bar and lingual bar together. Usually it is designed in the cases of short teeth crowns and a very shallow floor of the oral cavity. So in such cases, we can design the dental lingual bar. And the lingual plate, this is the example of a connector which covers most of the lingual aspects of the teeth, the gingival margins, and the lingual aspect of the ridge. The lingual plate is recommended in the case of short teeth crowns, shallow floor of the oral cavity, and possible future teeth extractions. So that was the lingual plate. And the last one, labial or buccal bar. It is used when extreme lingual inclination of the lower incisors and premolars prevents the use of major connectors like lingual bar. And this kind of major connectors is very, very rare because, as you see, this is ugly and non-aesthetic one, so it is very rare in use. Characteristic of major connectors, they are made from material compatible with oral tissue. They are rigid, stiff, doesn't alter the natural contour of the lingual surfaces of the mandibular alveolar ridge or of the palatal volute, doesn't affect on oral tissue, insertion, withdrawal, or infunction, cover no more tissue than is absolutely necessary, doesn't contribute to the trapping of food particles. They have support from other elements of the framework to minimize rotation in function and contribute to the support of the prosthesis. Next, the denture saddles. The saddle of the tooth supported denture stretched between the two supporting elements, and the chewing forces are directly transferred to the abutment teeth, and here you have an example of that. And the saddle of the tooth and tissue supported denture saddles must act as the supporting elements, as you see here. With increasing distance from the abutment tooth, growing importance of support provided by the toothless alveolar process, making the large, bulky denture saddles, allowing the uniform distribution of occlusion forces throughout the whole toothless area, give a maximum support in such cases. So as you see, sometimes the saddles are very, very big because they provide much more support for such kind of denture, especially in the mandibula. Okay, that was the first part of the lecture, and now let's go to the second part. And now we'll be talking about the surveying procedure and the clasp types. So, correctly constructed skeleton denture should be characterized by an easy possibility of denture insertion and removal made by the patient. Should be characterized by a resistance to dislodging forces, a good aesthetics, a design that prevents retention of the foot, a design that provides a minimum retention of a plaque. So the goal in the clasp type removable partial denture prosthodontics is to fabricate a prosthesis of metal and acrylic resin which can be inserted and removed by the patient, accurately resist reasonable dislodging forces, present the best possible appearance, preserve the health of the patient's remaining teeth and related structures. And to achieve this goal, we must formulate treatment plan for that restoration, prepare the mouth according to that treatment plan, and fabricate the prosthesis. And surveying diagnostic cast is a goal of a planning process, and surveying the master cast is a goal of fabrication of that prosthesis. Ideally, the clinician rather than the dental technician surveys the study cast in preparation for designing an RPD, but the final surveying on the master cast is done rather by the dental technician. So what does it mean, the dental surveying? Dental surveying, this is the procedure of locating and delineating the contours and position of the abutment teeth and associated structures before designing a removable partial denture. Surveying is the mechanical method of orienting the stone cast of the patient's dental arch on the parallelometer surveyor. So here we have an example of parallelometer surveyor, so we can accurately analyze teeth and soft tissue contours in relation to each other. The dental surveying is done on the casts with the measuring instrument called surveyor, parallelometer. This is the surveyor, parallelometer. The surveyor is an instrument used to determine the relative parallelism of two or more surfaces of teeth or other parts of a cast of dental arch. The surveyor allows a vertical arm to be brought into contact with the teeth and regions of the dental cast, thus identifying parallel surfaces and points of maximum contact. So as you see here, the parallelometer, we can check the contours of the teeth and we can mark the greatest convexity of a teeth because it is very important to find the undercuts and design the clasp in proper places. So let's talk about the parts of dental surveyor. I mark them using different colors, and also the different letters. So let's start from the letter A. A, the red one. This is the base, the platform, the base of the parallelometer. Then we have the B, vertical arm, in other words, vertical column. Then we have the letter C, horizontal arm, in other words, cross arm. This is the cross arm. Then we have the letter D. This is the surveying arm, the vertical spindle. Then we have letter F. This is the chuck, mandrel, tool holder, because I will show you on the next slide then that we have 4 kinds of tools which can be placed in the tool holder, in the mandrel, and they play the special role in the surveying procedure. Then we have the letter H, the cast holder. This is the surveyor table, adjustable table. Here we have also the cast clamp, model clamp, and also the ball joint, because this table, thanks to the ball joint, can be movable, and thanks to it we can find the proper the proper place of the gypsum casts, and thanks to that we can find the proper path of insertion of the skeletal denture. Okay, so I hope that you now remember the parts of dental surveyor. Again, the base, the vertical arm, the horizontal arm, surveying arm, chuck, mandrels, in other words, tool holder, the cast holder, the table, the ball joint, and the cast clamp. At the inferior end of the vertical spindle, there is a chuck in which various surveying instruments may be secured. So here. Here you have the surveying tools attachments. We have analyzing rod, graphite marker, undercut gauge, and trimming knife. First of them is analyzing rod. This is the metal rod with the parallel sides used to analyze the cast to establish the path of placement of the denture. It is used to identify undercut areas, as you see here. This analyzing rod can show us the undercut here in the tooth. And also, analyzing rod is used to determine the parallelism of two surfaces. We can check using this element if those two surfaces are parallel to each other. Then we have the graphite markers. This tool is used to mark out the line on the cast, mark out the position of a greatest convexity of the tooth, and the alveolar process. So graphite marker is used to mark the greatest convexity of the tooth or alveolar process. Okay. Yes, so the greatest convexity of the tooth, or also alveolar process. And the undercut gauges, it is used to measure the undercut on the casts. It is available in three types: 0.25 millimeters, 0.5 millimeters, and 0.75 millimeters. This is the undercut gauges, and as you see, it consists of the metal tip and the plate, which is placed at the tip of the device. And thanks to this plate, we can measure the depth of undercut. As you see, three types of those plates, and thanks to them, we can measure the depth of the undercuts. And wax knife, wax trimmer, it is used in the late stages of RPD construction to eliminate or block out areas of undesirable undercuts with wax on the cast before the framework is made. So this tool is placed also in the chuck mandrel, in the polarimeter, and then we used such a wax knife to cut the wax in proper position to make the parallelism of two or more surfaces to each other. So here you see those elements. So this is the analyzing rod, graphite markers, undercut gauges, and trimming wax knives. Okay. When surveying a tooth, the tip of the marker should be level with the gingival margin, allowing the side of the marker to produce the survey line. What does it mean, a survey line? This is a line produced on a cast by a surveyor marking the greatest prominence of contour on the tooth or the alveolar in relation to the orientation of the cast to the vertical spindle, so that in relation to planned path of placement of restoration. So this is the survey line which is produced on the greatest prominence, greatest convexity of the tooth. So this is the survey line, and we can say that this is also we can call it relative high of contour. So as you can see, relative high of contour is the same meaning than the survey line. This is a line drawn on the tooth to indicate the greatest circumferences in a given horizontal plane. Okay, the survey line also helps locate areas of undesirable tooth undercuts that must be avoided or eliminated by contouring or placing restoration on the teeth. All rigging components of the partial denture must be kept occlusal of the survey line. Normally, only the terminal third of the retentive clasp is placed gingival to the survey line. Later, I will show you examples. A survey line marks the high of contour, the greatest prominence, convexity of a tooth or bony prominence, at the selected path of placement. So tilt of the cast. If the tilt of the cast is changing the path of placement of the denture, the high of contour survey line will change also. And it is a very important thing to remember. So once again, if you see the gypsum model in such a position, then we can mark the greatest prominence of the tooth. If we change the position of the gypsum model, and we can change it because I told you that the surveyor has got the table with the ball joint, so the table is movable, so we can change the position. Then we change also the path of placement of the denture. And in such cases, there will be another survey line, another greatest prominence of the tooth in a given horizontal plane. To understand better this situation, I will show you an example of egg and show you that this egg, imagine that this is the tooth, he's got the anatomical high of contour, the absolutely greatest convexity in a given horizontal plane. But when we change the position of the model, so according to that tip, according to that graphite marker or analyzing rod, the position of the greatest convexity is changed in such cases. So related greatest convexity appears after changing the position of the model and doesn't coincide with the largest line of anatomically circumferences of the tooth. So the greatest convexity of the teeth, so this is the own tooth convexity resulting from the anatomic tooth shape, and relative tooth convexity resulting from the tooth position in relation to the surveyor's analyzing rod. Again, you can see it here. This is the anatomical high of contour, and when we change a model a little bit, the high of contour is also changing, and then we called it relative high of contour. Again, anatomical high of contour, absolute, the greatest prominence of the tooth, and it is only one, and the relative high of contour, which is related to the analyzing rod, and it depends on the tilting of the model. And in that case, we've got many possibility of the relative high of contours. And also we have the greatest convexity of the alveola. Okay, and above the red line, above the cervical line, it is the suprabulge, non-undercut area, non-undercut surface. And below the red line, below the cervical line, we've got the infrabulge, the undercut area, undercut surface. Types of cervical lines on the facial and lingual arch of the abutments are the retentive cervical lines and reciprocal cervical lines. Retentive cervical lines are used on the surface of the tooth on which the direct retinal clasp arm will be located, and reciprocal cervical lines are used on the tooth surface opposite to the retentive cervical lines where the reciprocal component will be located. Once again, we have the anatomical high of contour, the absolute one, and the relative high of contour. And the marking on the model, the biggest bulge of the teeth and the alveolar process is used to determine the undercuts. So we need the greatest convexity of the tooth to find the undercut. And what does it mean, an undercut? An undercut is formed when the base of an object, is smaller than its top. Yes, so this is the base of an object and the top. And in such cases, we got the undercut area, which is placed here. How it is look on the tooth? Where there is an undercut, this is the space below the greatest convexity of the tooth, gingiva, placed between the analyzing rod and the surface of the tooth. So between the greatest convexity, gingiva, analyzing rod, and surfaces of the tooth, there is a space, and when we find such a space, we can call it undercut. So this is undercut area. So undercut, when it is used in reference to other oral structures, undercut means the contour or cross-section of a residual ridge or dental arch that would prevent the placement of the denture. Once again, this is an undercut area of the tooth, and here, for example, an undercut area of alveolar process. We've got the tooth undercuts, so proximal undercuts, and of course soft tissue or bony undercuts. And also we've got desirable undercuts were used for retention. So when we would like to find undercuts because in the area of undercut we can place the tip of the clasp, which provides the retention of the skeleton denture. And in such cases, those undercuts are called desirable undercuts. And we've got also undesirable undercuts, almost all undercuts in other way. So those undesirable undercuts should be blocked out, because in opposite way, they will they will disturb of the placing the denture on the proper place. Okay. So the tooth surface may contact to the analyzing rod with a point, like you see here, or linearly, like you see here. The tooth surface may be parallel, so the tooth surface may be parallel to the analyzing rod, or at an angle in relation to the analyzing rod. You see angle here and angle here. And thanks to that, we can find the clasp surfaces. So these are the surfaces which contact the clasp arm while placing the denture and its final placement. They differ from each other with their relation to the analyzing rod and their placement on the surfaces of the abutment tip. We can find the retentive surfaces, guide plans, so guide surfaces, or in other words, leading surfaces, reciprocal surfaces, and entering surfaces. Okay, so now I try to tell you first about the retentive surface. Okay, so when we find the undercut, we also can find the infrabulge surface. And the infrabulge surface placed between the line of the greatest convexity of the tooth and the edge of gingiva, in relation to which there is a leading, the guide plan, placed under the retentive serval line on this surface, will be placed direct retainer, the clasp. So once again, when we can call the surface as a retentive surface, when we find an undercut and find the surface between the greatest convexity and gingiva, in relation to which there is a leading, the guide plan, then we can call this surface a retentive surface, and then we know that we can place here the direct retainer, the clasp, the tip of the clasp. And of course, this surface, retentive surface, is placed under the retentive serval line. This is the serval line, and this surface is placed under this one. So on the tooth, as you can see here, the retentive surface is placed under the retentive serval line. Again, retentive surface. So first we find an undercut, then we can call the retentive surface when it will be the guide plan for it. Yes. So when we find only the undercut and there is no leading, no guide plan for that undercut, so there is no retentive surface. But when we find the guide plan, we can call it a retentive surface, and we can design on it the clasp, so retentive element. The retentive surface should have some features, because it should have a proper length, width, depth, and depending degree. So the length, this is the dimension measured from the gingiva edge to the line of greatest convexity, and this length in the case of the retentive surface should be at least 3 millimeters. 3 millimeters. What about the width? The width is measured from along the line of the greatest complexity, and also the width should be at least 3 millimeters. Then we have the depth, the distance between the tooth surface and the analyzing rod being in contact with the line of the greatest convexity, and minimum of the depth is 0.5 millimeters. And depending degree, so this is the depending degree, depends on the angle size between the retentive surface and analyzing rod, and it should be 8 to 15 degrees. So when this surface has got such features, we can call it a retentive surface. And now guide surfaces or guide plans. These are two or more vertically parallel surfaces of abutment teeth shaped to direct a prosthesis during placement and removal. Guide surfaces may occur naturally on teeth, but more commonly need to be prepared. Guiding plane surfaces are parallel to the path of placement and parallel to each other. However, they may or may not face each other. Preferably, these surfaces are made parallel to the long axis of the abutment tooth. And now, the leading surfaces or guide plans may be placed on the opposite wall of the same tooth where the retentive surface is located. So this is that example. So once again, the leading surface or guide plans can be placed on the opposite wall of the same tooth where the retentive surface is located, on analogical tooth surface on the opposite side of the tooth arch, like you see here on that example, and on the wall of the next tooth surrounding the gap. Only in those three places we can find leading surfaces or guide plans, and only on those surfaces we can design the reciprocal cards of an arms, because then they provide the stabilization of the denture, and the retentive arm provide the retention of the dentures. So once again, I will explain everything on that picture. Here we have the retentive surface, R, the blue one, and the leading surfaces or guide plans may be placed on the opposite wall on the same tooth where the retentive surface is located, on the analogical tooth surface on the opposite side of the tooth arch, so here, and on the wall of the next tooth surrounding the gap, so here. And reciprocal surfaces are placed above the cervical lines on the tooth surfaces opposite to the retentive surfaces, where the reciprocal components will be located. It will provide stabilization of the denture and resistance to dislodging forces. And entering surface, this is the part of the surface on which the clasp arm is moved while placing the denture. So this is the entering surface on which the clasp go down to the retentive surface. This is the entering surface. Okay, and now surveying stages. So first we should find the retentive and guide surfaces, so we should search for them. Then we should decide about spatial location of the entering surfaces. Then decide about the quality analysis of the found clasp surfaces. So we should measure the length, the width, the depending degree of the retentive surface, and decide if it's right or wrong. And at the end, we should analyze the tilt of the denture area side surfaces, so toothless parts of the alveolar. So first of all, we should place the gypsum cast on the surveyor table in the initial location, so that occlusal surface in horizontal position, and we should find the undercuts with the help of analyzing rod. So in that position, using the analyzing rod, we try to find an undercut, of course, on abutment teeth. In the case of the negative estimation judgment of the undercuts, they are placed on some abutments or on the wrong places. The position of the cast should be changed. There is a tilt in relation to analyzing rod. As you see, the tilt of a gypsum model to the analyzing rod until the best surfaces for the clasp of the abutment teeth are found. So how it is looked. Look at this picture. This is the horizontal position of the tooth. When we put the analyzing rod on the surface of the tooth, there is no undercut. So we can't find the retentive surface for that tooth and can't design the clasp. But when we change the horizontal position to the side, the effect is the bigger portion of an undercut occurs. So we can find the better undercut or the bigger undercut, and of course we can find the retentive surface. But remember, that retentive surface should be a guiding plans, leading surfaces. So then we should find the leading surfaces for that retentive surface. Then we can decide to put the clasp or design the clasp of that surface. Again, the horizontal position of the gypsum model, as you see, there is no undercut on an abutment tooth, but when we change the position of the model, we can find an undercut and can think about the designing the clasp on that surface. Yes, so again, tilting the models, we can find the better undercut. What about the quality analysis of the found clasp surfaces? The length and width and the depending degree of the retentive surface should be estimated. The size of the tilt angle is also estimated. This feature depends on the position of the cast towards the analyzing rod and change with the change of the cast position. The examining of the quality of the clasp surfaces concerns estimation of the usefulness degree of all surfaces together and lets us estimate the best cast position so that the best path of placement insertion of the partial denture. And the path of placement, path of insertion, this is the specific direction in which a denture is placed on the abutment teeth or dental implants. The path of denture insertion show the direction of putting the denture on the place. And the path of placement followed by the denture from its first contact with the teeth until it is fully seated. This path coincides with the path of withdrawal or may not coincide with the path of displacement. There may be a single path or multiple paths of insertion, so path of placement. And path of displacement, this is the direction in which the denture tends to be displaced in function. The path is variable but is assumed for the purpose of design to be at right angles to the occlusal plane. Okay, and the last part of the lecture, the clasp types. But before we start talking about the clasp types, I should explain to you what does it mean areas of the abutment teeth. We've got the first area of the abutment teeth. This is the area of the tooth lateral surface placed directly to the gap. So as you see here, when we have the gap between the teeth, so the first area is directly placed to the gap. And the second area, this is the area placed on the other part of the tooth. Yes, so the first one is placed directly to the gap, second is placed on the other part of the tooth. Okay, and the clasps. They provide retention of the denture. They act like direct retainers. They provide resistance while removing the denture along its path of placement. The clasp consists of two arms, retentive and reciprocal, placed on the opposite abutment walls, and it is called single clasp. So we can't say that we've got two clasps, but this is the single unit, single clasp, which consists of two arms, retentive arm and reciprocal arm. So the clasp consists of two arms which have the following functions: the retentive function, stabilizing function, and leading function. Again, a direct retainer is commonly called a clasp or clasp unit, and it's composed of four elements: retentive arm, reciprocal arm, the rest, and minor connector, of course. The retentive arm of the clasp, so the one of them, the retentive arm of the clasp, is situated on the retentive surface. Yes, you remember the retentive surface. Is a spring-like arm, flexible, working like a spring. It serves to fasten the denture on the base and maintain it in this position while chewing, eating, smiling, speaking. So in all mouth activities. Stand up to the forces which pull the denture out from the base. And the parts of the retentive clasp arm, we've got two parts: the main part and the intermediate part. The main part, the tip of the retentive arm, is placed on the retentive surface, so below the cervical line. And the intermediate part of the retentive clasp arm is placed over the greatest convexity of the tooth. So it is placed above the cervical line. And it is a very important thing to design the proper clasp to provide the retention of the denture. So once again, remember, we've got the clasp unit, which consists of two arms, retentive arm and reciprocal arm. The retentive arm consists of two parts: the main part, which is placed below the cervical line, so it is placed on retentive surface, and the intermediate part is placed above the cervical line, and it is placed over the greatest convexity of the tooth. So this is the two part of the retentive clasp arm. And we've got also reciprocal clasp arm, which all of that is placed above the cervical line, above the greatest convexity of the tooth, and reciprocal arm of the clasp is responsible for the stabilization of the denture. Okay, I know that this is a very difficult subject, but you should know such things. And we have four types of retentive arm clasps: the straight retentive arm, return retentive arm, circular retentive arm, and overgingival retentive arm. The straight retentive arm is used on all abutments. So we can design such clasp, such retentive arm of the clasp, in all abutments. This kind of arm use the retention in the second area of the abutment tooth. Remember, the second area of the abutment tooth was placed opposite to the gap. Yes, so when we design such a clasp, the tip should be placed in the second area of the tooth. And the main part, the tip of an arm, is placed 0.15 to 0.4 millimeter deep, like you see here, so below the survey line. This is the straight retentive arm, and this is the most common used clasp in the case of the skeletal denture. The return retentive arm, it is also used on all abutments. This kind of clasp uses the retention in the first area of the abutment tooth, so close to the gap, the first area of the abutment tooth. The main part, the tip of an arm, is placed 0.25 to 0.5 millimeter deep. Then we have the circular retentive arm. The circular retentive arm, it is applied to single standing molars. So not for all abutment, but only for single standing molars. The arm covers three surfaces of the abutment tooth. Three surfaces, it means, for example, mesial one, occlusal one, and buccal one. So three surfaces of the abutment tooth. The intermediate part of the retentive arm can act like stabilizing arm because it is placed above the survey line. This kind of an arm uses the retention in the first area of the abutment tooth, so the area which is placed close to the gap, the first area of the abutment tooth. And the main part, the tip of an arm, is placed 0.5 to 0.8 millimeter deep. And the last but not least, the overgingival retentive arm. This is the most aesthetic one. It can be used on all abutments. The main parts of the retentive arm is placed on the retentive surface, but the intermediate part is placed above the alveolar process, as you see here. It uses the retention in the first or at the second area of the abutment tooth. It depends on the shape. So it is used the retention in the first area, but also in the second area of the abutment tooth. And the main part, the tip of an arm, is placed 0.4 to 0.8 millimeter deep, and the intermediate part is placed 0.5 millimeter above the alveolar. So to sum up, we've got the four kinds of retentive arms: the straight retentive arm, return retentive arm, circular retentive arm, and overgingival retentive arm. On this picture, you can see how we can measure the depth of an undercut and measure the depth of placing the tip of the retentive arm of the clasp. Okay, and the reciprocal arm, it is located on the reciprocal surface opposite the retentive surface, carries horizontal chewing forces on the abutment tooth. It is stiff, rigid arm which is inflexible while using the denture, and the reciprocal arm loses contact with the tooth surface with the first movement along the path of displacement. Okay, and this is the last slide, which tell us about the surveying arms. So surveying is undertaken to obtain information about the optimum path of insertion of the denture and also the design, material, and position of the clasp. The decision on these aspects of clasp can be arrived at from measurement of the horizontal extent of undercut on abutment teeth and the identification of sides on the teeth to provide reciprocation either from guiding surfaces or from cross-arch reciprocation. Okay, so this is all for today. I know that this is past 8 past 8. Yes, 8 past 8. But I would like to finish this lecture. So I hope. I know that there was the many information